Bere. He is a senior research scientist with Agriculture and Agri-Food Canada. Dr. Brand did a lot of research on ultra-early wheat seeding systems in Western Canada. Welcome, Dr. Brand, and thanks for joining us today.
Good morning, everybody. It's it's a pleasure to be here and to be invited by the Battle River Group. I actually don't recall interacting much with this association in the past, so it's nice to connect with this group and to talk a little bit about a concept we've been exploring for the last 5 years or so now, about this whole concept of ultra early spring wheat systems. And so the core team, aside from myself, is Graham Collier, who's a PhD student that we've recruited to be part of this now, and he's using and taking these concepts to form the majority of his PhD thesis. Rob Graff, who just presented, who needs no introduction, was key in providing us with some germplasm lines that we wanted to explore and compare to regular conventional bred wheats that we have that are commercially grown. And Dean Spanner as well has been involved in this from the beginning. So there used to be websites talking about optimum soil temperature. I know growing up as a kid, in southern Alberta, on an irrigated farm. I mean, really what we always talked about in the coffee shop talk was the calendar date by which we needed to get into have our cereals in by. And really, where I was from, it was like, well, if you're in by May 10th, you're good. And that really was driven, I think, a lot around meeting crop insurance deadlines. With respect to extension documents, it was usually about, warmer soils or more conducive. There's a bit of a danger associated with colder soils and planting too early. At least that's what was going around as sort of preconceived notions in my mind, what I had learned growing up and working in the industry. And so the other aspect that we know that's coming along is like a lot of our yield advantages or yield increases on the genetic side are really a function of adding growing degree day requirements for wheat, for canola. So you have to make sure you're in early, because you could be faced with a longer harvest if you're growing these higher yielding varieties. So these were some of the things. And then it was just a trip down to Montana in 2011 or 12 where I was going to a wheat stem sawfly meeting at Montana State. It was like the end of March or something like that. And really all those guys down there, and a lot of them were still to this day even, but back there particularly doing wheat fallow systems. And they were already out there. I can't recall if they were prepping or actually planting. And I thought, that's something we should be exploring, this idea of, let's set aside calendar dates as what drives our time to plant and start thinking about something different in relation to soil temperature, as an example, as the trigger instead of a calendar date. And then the other elephant in the room, if you will, is what is going to happen with climate change in Canada and around the globe. And there's a lot of models out there, but I would argue, even though some people, view these as sort of, fear mongering and the sort, or not accurate, or Rob referred to garbage in, garbage out. Some of that modeling, I think, falls into that category sometimes. But the reality is, when you look at things, so this is change in yield anticipated using a whole bunch of different modeling systems. What's the effect on climate change? And the reality is, if you look at a lot of these, the red, the yellows, that's not good. But where you're green, light green, even if you didn't do anything with your management system and didn't change or adapt much, the reality is the northern latitudes are going to fare a lot better than a lot of other areas. And so probably what we need to start thinking about to maintain, yields and even exploit higher yield potentials in the future is the idea of just, starting to think about concepts and exploring just tweaking our management system that allows us to take advantage of how we might change with respect to prairie climate and how that might influence seeding operations in the future. And and again, here's another one, different model, but same story that, if we didn't change anything, we would still be okay. And a lot of this is going to depend on the amount of CO2 levels that rise, and of course, driven by temperature. But generally speaking, we have the potential to be in a lot better shape than a lot of other areas. And the last bullet of this slide is Don Bowles, who I've known for a long time. I gave this presentation, I think, last year at Three Hills in Central Alberta, and he's not exactly a climate activist or anything like that. But what Don fairly said was, and he just retired from farming. When I retired, compared back to when I first started farming, I think there are years where I could seed 6 weeks earlier. So and that's one generation. So I think we have to concede that something's happening, and it requires us to do a rethink and probably perhaps a little bit of a paradigm shift around how we view or preparing for planting. And the ironic thing was this concept that we developed was at the same time, this is Australia, and my colleague in the middle there, Dr. James Hunt, he actually was exploring the same concept in Australia, but for different reasons. And the irony, to me, it's a true irony because of what we tried to advocate for winter wheat, sometimes just banging our heads against the wall. Myself and even more Rob Graff is that he's advocating a shift and early sowing systems, but even more extreme where they're changing the growth habits. So spring wheat was sort of the system of the day, but they're exploring a shift over to winter wheat just to try and asynchronize or disrupt and try to get crop phenology completed, with respect to flowering and then maturity before you get the terminal droughts that they have. And of course, they deal with water issues. So for different reasons, perhaps, but the concept isn't something that is particularly unique. And so it's not some, blue sky, thing that I've just dreamt up in my basement office, as you can see where I live mostly nowadays. So our original hypothesis was a proof of concept where if we shift to ultra early plantings, which we're calling it, and perhaps there's cold tolerant genetics out there that it would even enhance that and facilitate that, plus combine that with optimum agronomics, we feel that at least our hypothesis was that we could either maintain or possibly even improve attainable spring wheat. And as importantly, system stability. If you've heard me talk at all, you've heard me beat the drum of system stability being as important as yield itself from field to field, year to year. That's, we want to be adopting those practices, which involves a lot more complexity perhaps, but the system stability is truly something that's more important than a one-off yield in one shot, one time, in one place, so to speak. So there were two big things that we were looking at, and the first phase of this, and the big thing was the genetic side, looking at just something real basic like conventional genetics of a variety at the time, Stettler, and comparing that to some variety or lines that Rob had developed as part of his challenge as a winter wheat breeder, because he doesn't get a winter nursery, is to removing that requirement, vernalization requirement, and actually having basically winter wheats that don't have a vernalization requirements, and therefore they act more like a spring wheat. And so he provided us with some, and we selected some of those to be part of this. And there's an example of what they looked like compared to Stettler. They probably look enacted, because they're not part of any class. No quality work's been done on them, but I would probably view them as probably either more like a CPS type wheat or a general purpose wheat, because they definitely had higher yield potential than a bread wheat like Stettler. So anyway, how did we go about trying to put all this together as an actual system? And so we took these lines and varieties, and basically our concept here was soil temperature would be the trigger at which we would go plant, ignoring whatever calendar date it was. And so starting when the top 5 centimeters hit 0 degrees, and every 2 degrees after that, we would try and get out there and hit a new planting date, and then compare, all the phenological and crop responses at each of those to see which provided us with a superior system. And so what happens, well, you get a range of when you actually end up planting. And so in Lethbridge, the first year that we did it was the trigger to go out and plant occurred on March 6th. And the scary part of this, for sure, was, as you can see in that middle column, is that we had, 37 days where the temperatures were below 0 after that first seeding. So we're definitely exposing this to some extreme abiotic stress, which historically has been viewed as something that's too insurmountable. And so it wouldn't be recommended as a practice because of that. But keep in mind what we've also done, and I didn't even test with and without, because of all our work on seed treatments, we just decided everything gets a dual fungicide insecticidal seed treatment, or at least a dual fungicide, because we know both chemistries of the neonicotinoids and as well as the tibuconazole, prothioconazole, they do actually change metabolic pathways within that plant to make them more resistant to abiotic stress, specifically things like more improvement around frost tolerance and so on. So we're buffering probably what the plant has to offer from a genetic standpoint with what the management of using a seed treatment offers as well. And so when we look at the yield, not just looking at yield, but back to the stability comment, your yield is on the y-axis there, and stability, or the proxy for it, is on the x-axis, coefficient of variation for each treatment. One thing to make note of right away is you can see all those lines like that start with 1289 in the upper left is in the green box, which is the highest yielding and most stable treatments, are all the cold tolerant lines. But that really is a function of that higher yield potential for starters. But if you look at Stettler, it's clustered fairly close together in that box below, or the quadrant below. So you'll see that Stettler planted at 2 degrees offered probably the most stable system and stable yields for Stettler. Whereas something like the 8 degree, the 10 degree, and the 0 degree, all circled in red, provided instability. If you strictly looked at the yield, the 0, the 8, the 6, 4, 2, for example, would all look pretty close. But when you start thinking about system stability and plot that as well, then you can get a sense of what is going to provide me the most stable yields from farm to farm, field to field, year to year, et cetera. And the other thing with this is that honestly was a surprise to us is we're growing this as far north as Dawson Creek, Scott, Saskatchewan, Lethbridge, Edmonton, and so on. But when you take all that and combine the analysis, we didn't lose any yield at all by going in as early as 0. So what we've done is we've shifted, and we're able to plant ultra early, but we're maintaining our yield potential. And like the previous slide shows, we're probably actually significantly increasing our overall yield stability as well. Now the caveat here is that it's not going to work every year at every farm, but we know, and I'll show a slide later on, we know that it's actually worked far beyond just southern Alberta as a system. It may not work every year, but when it does work, it's providing us with data and responses that really require a rethink on how we view planting. So that was a proof of concept, and so we now have shattered the myths around out there, and there's a lot of them, believe me, that it can't be done. So now we wanted to fine tune the actual agronomic system around that. So we had planting rates that were, I would say, low by today's standards and more conventional by today's standards. The today's standard should be 400 seeds per square meter or 40 seeds per square foot. Two varieties. And in this case, we just went with the cold tolerant lines. And then depths, and my mistake there was I probably didn't separate those depths enough. It was just basically 1 inch versus 2 inch. And again, back to these trigger soil temperatures starting at 0, 5, 7.5, and 10 this time. And here's another example. So here we were this time, the guys were out actually the second year. February 16th was the trigger for them to go out and plant at 0. So regardless of what the calendar is telling you, more about what the soil, what your field is telling you about when to go out and plant. And the yields here between the two varieties, so not a whole lot of difference going on. Basically what you see there with most of them is that the earlier planting, so you see the 2 at the end of a lot of those labels. So that's the earlier planting. And then the other thing that you're seeing is for the most part, high seeding rates are giving you more stability and higher yield. And generally speaking, the shallower depths gave us, so to fine tune it, that high seed rate, seed treatment, of course, shallower seeding, and that ultra early soil temperature as a trigger. And in this case, actually, in this experiment, we observed a yield drag from our very earliest plantings down to, that 7.5 to 10 would have been something more common back in the day. So the big thing is that this does work. It does provide at least as good a yield, and probably in some cases better yield. And overall, certainly it provides more system stability. So definitely no yield penalty planting after soils reach 2 degrees. In fact, we saw a lot of opportunity even at 0, but not always. And so that's what this slide here is we're using pretty aggressive knife openers with the Conservapack knife opener. So if the soil's still pretty tight or frozen and you go out to do this at 0, this is what it could look like. So you do have to weigh that in mind. Although this is, I think out of 16 site years, we only saw this once. The rest of the time it was good. But the benefits, there's all kinds of benefits that come with this that, if you hear us, particularly Rob, talk about benefits or, Ducks Unlimited around winter wheat, it's kind of the similar thing. You're synchronizing better to early season moisture. It's probably a better fit with those later maturing varieties. And again, probably improved wheat competitiveness as well. The next part that we're going to explore with this is Graham Collier. He's going to be looking at a lot of facets around the management system because things change. You don't obviously have any weeds when you're still at 0 degrees with respect to soil temperature. So things like fall applied residual herbicides he's looking at, nitrogen sources, there may need to be modifications to that, and just further exploring what's out there with respect to genetics that may be more amenable to this. Because what we've learned so far is that probably as a function of where our bred wheats are bred and what they're exposed to along the breeding continuum, is that they're very well adapted to these cold soils. So this notion that seeds would sit there or seedlings would sit there and rot in cold soils is unfounded. One last thing that we looked at quickly was back to that picture was sort of motivated me to look at comparisons between disc openers and knife openers. And so we have a pillar laser at the top of that picture on a drill we built compared to a drill we built where we're using conserver pack openers. And really so far that's kind of surprised me, although the yield potential was terrible because of the severe drought, was that so far we're seeing no difference between the two. And then the last thing was just how has uptake unfolded with respect to farmer experiences. Well, it was kind of scary because it started last year when farmers started to try this. Jay Schultz was one of them, and he went in at the prescriptive time, like we had said, with using 2 degrees as the trigger, and then everything was up, and it was up early, and then we started getting those events of really fairly severe frost where I think some were recording -8, which I know from experience will terminate a cereal cover crop, for example. So needless to say, I was quite worried about what we were recommending and how it was now unfolding when you have those kinds of really, notable frost events that we don't normally experience. But the reality was all it did was burn. There was a bit of leaf necrosis on the top third of some of the leaves, but otherwise they did just fine. And the yield potential from all reports was actually the highest they've experienced. So that's all I had, and I'd just like to acknowledge our funders. Big supporter was Alberta Wheat in all this, but at Western Grains has been very supportive in the past, as has Alberta Innovates as well. So with that, hopefully everything went okay. That's it for me.